This is JEE 2025 paper 1 question. Uh, the question says that we have a glass sphere of refractive index root 3. This is the refractive index of the glass. N is root 3. And a ray of light is sent from S and it strikes the glass surface over somewhere here. And finally, from this point O, the ray is totally reflected and is fully polarized. So it is reflected from the point O and it is fully polarized. We have to find the value of sine theta. So I'll start with the diagram, a little bit slightly different from the question, but nevertheless the solution will give the same result. So I'll start one by one. So this is our ray which is sent from some point, suppose S. This is our point S, and from here this ray is sent. This is the normal. Suppose this point is the center of the larger circle having radius, suppose R, and if it is reflected, then this is our reflected ray and the angle is theta. Now if we draw the normal, so this normal will pass through the center of this, I'm writing it, suppose it is O1. So it will pass through the center of O1, and after intersecting this surface it will get refracted, and this is our refracted ray. It will strike at point O, and here it is said that at point O this light is fully polarized when it is reflected. So first of all we will calculate this Brewster angle, that is tan IB. This is N2 by N1, that is root 3 by 1, because N2 is, this is our N2 suppose, and this is N1. So N2 by N1 is 60 degree. The root 3, that is tan IB, or IB is 60 degree. So IB is 60 degree. Now in this circle, this is the radius and this is also a radius. So these two sides are equal, so this angle will also be 60 degree. Now this line O1, and suppose it is some O2, if I am writing it as O2. So this will be, although it is looking somewhat not a straight line, but it is a straight line because this is the tangent and this line is normal to this tangent, so it will pass through O1, and this is point of tangency for both the circle. So of course this line again will pass through the center of the larger circle, that is O2. So O1 O2 will be a straight line. So since O1 O2 is a straight line, so this angle will be 60 and this is 60, so this will be 120. So this angle is 120. Now if we join the endpoints from where it is striking, so we will get this angle as 30 degree. Why it is 30 degree? Because this is the smaller radius, that is R by 2. Similarly, so this is a smaller radius. Likewise, this will also be the smaller radius. So these two sides are equal, so these two angles will be equal, that is 30 degree and 30 degree. Now this 30, 30 and 120, it will constitute 180. So the angles are known. Now coming to the refraction, I am talking about this angle, which I am representing it as alpha. So if we write Snell's law, then root 3 into sine alpha equals to 1 into sine 60 degree. Root 3 is N2 and 1 is N1. So when we calculate it, we get alpha equals to 30 degree. So alpha is 30 degree. Now alpha 30 degree is known, and this angle 30 is also known. So 30 plus 30 is 60, and this is total straight line passing through the center. So what we will get is 180 minus 60, that is 120 degree. So the angle made by this line, we can call it this one, this is 120 degree. Now naming, suppose the end point as A, this is second as B and as C, and this center of the circle as D. So in triangle BCD, what we'll see, we know all the angles 120, 30 and 30. So sine 120 upon BC, this length BC, equals to sine 30 upon BD. Sine 30, this sine 30 upon BD. So after calculation we will get this BC equals to root 3 into BD, where BD is the radius of the circle, that is r by 2. So BC is known now. Now coming to the second one, in triangle ABC, what we will see is, in triangle ABC, sine theta, this angle is our theta, so sine theta by BC equals to sine 120 by AB. This is our angle 120 and this is AB. AB is the radius, so sine theta is sine 120 by BC into BC by R. Now substituting the value of BC and R, we will get sine theta equals to 3 by 4. So this is our final answer. Now the most important thing is that whether this total internal reflection is taking place or not, because we are getting sine theta equals to 3 by 4, so critical angle should be less critical angle should be less than 3 by 4. So if we use Snell's law at point A, then root 3 into sine theta C equals to 1 into sine 90. So sine theta C is 0.577, which is obviously less than the sine theta that we have calculated, which is 3 by 4, and that is 0.75. So obviously the total internal reflection is taking place at point A. So this is the end of the video. Thank you.